Okay. Um, so I think this is since this is also the last sessions of AEI conference. I can see Fumi is here, also Cecilia is here. So if you like, you I think we all can join for this session since I think we're gonna have another 45 minutes.
Yeah, I think all the previous speakers, yeah, we would like to
Yeah.
invite. I think Trish, I saw Trish
Yes.
well in the audience.
Yes, Trish. Yes, yes, please. So yeah. Yes, please. Um, okay, I got a couple of questions for these sessions. Maybe I could read the questions. I think maybe two, three questions first. And then after this question, and for the audience, if you have more questions, please feel free. And then otherwise, we're gonna have some more discussion on that. So the first question, I think this is also I think it might come to me, but I think it's quite general for everyone. Like Steph, he asked that the sensors and humans, like eyes, have been compared in the sense of law specifications. However, the eye already does some of pre-processing, such as like in the phobia and cell. His question is that would that be an interesting development area when, like, can we use the camera to provide, let use the camera as an input directly to the neural network instead of, like intermediate image, like pre-processing and then feeding this to the neural networks. Okay. So this is the first question. So maybe we can, like discuss on this question a little bit. Okay, I can see. Good. So uh, I can start to like comment on this a little bit from what I understand here. Uh, I think in general having the image data into like the network to process something or generate the model outcome, that would be something really good. But I think we all know that is like image come with the high dimensional data, the high dimensional inputs. And that is the trick where the deep learning kick in, where you try to extract some features to do some, lower the dimensions into the feed-forward network, such that we can trainable the network. I think that's the trick that people have put in deep learning. Yeah, I don't know if any others have some opinion
Yeah,
on this comment.
um,
Yes, please.
yeah, I can say a few things. So the important thing is like, so we have a foveated vision, but at the same time we can saccade, right? So we can saccade our eyes to pay attention to things, but most robots don't saccade. They have a fixed camera, and then they have to take the full image, and then that wastes a lot of time and resources in computing. That's true. So we have two ways to go, right? So one is to waste resources and have not saccading fixed eyes, or have foveated vision and saccading, and then that needs attention, right? So then I think the reason why a lot of robots don't saccade is that attention is another difficult thing. But attention is key to deep generative AI. All the transformers work with attention. So I think a meeting point between embodied intelligence and generative AI is this attention, and then having hardware that pay attention to things like foveated vision and saccading. So that's my view.
Maybe another thought on the topic is that some of this additional processing that happens in the retina may be related to the fact that the sensors are so far from being perfect, right? Like each and single sensor is not this high resolution camera, is actually quite simple and noisy and weak sensors. So these additional kind of behaviors kind of emerge to be able to deal with that. So maybe our artificial systems we could try to make them imperfect by design and see what kind of control would sort of emerge in the network if it's trained to control such a set of imperfect, simple, kind of not beautiful sensors.
Yes, so I think this is a really good point on the imperfect sensor or general, like dealing with some background noise. I think this is like the thing that the brain does, like the forward model, right? Reference copy and then try to, like compare with that actual feedback and suppress those. And I think that could be a very interesting point that, like thing can be little by little put into the embodiment aspects and robotics. Yep. So yeah, you want to comment something, Tris?
I know. I think it is true. So this is a dilemma we have, right? So the active vision and attention versus passive vision and lots of processing, right?
So how do you think a fundamental model is an effect for such problems?
Like I have done some work when I was a postdoc at Johns Hopkins about saccades. We looked at how people use saccades and what are the driving things like. So our evidence show that like the ocular motor system, that the motor controllers that control our eye movements have some access to anterior cerebellum areas where the model-based predictive controllers in the cerebellum can send information to the ocular motor system to look at what is relevant for the task in future. For example, like we have sensory motor delays, right? So in the body, and then the computed commands from the primary motor cortex take about 120 milliseconds to reach the muscles, but the eyes can look at the consequences of those motor commands, before even the motor commands can reach the muscles, and then for task planning. So it is basically eyes are looking at future consequences of actions and the task relevant information. So this needs a lot of different modeling. Like robots are not doing that right now. So it needs a lot of predictive controllers, like predictive coding, that kind of things. But that is where the embodiment and model-based control converge, and generative AI in future. So that's definitely a direction our community should think about.
I just want to add one thing of what Thresh says, and saccade is a very well-known behavior in animals, but I think same thing can be applied to the tactile touch sensation, and lots of principles are in common in many other sensor modality, but I don't think so many roboticists have focused on this problem, like the reason why saccade happen is because heterogeneous distribution of optical receptor in our eyes, but our body tactile sensation is also not homogeneously distributed across the body, and that is kind of a very interesting principle where we could explore. And I'm sure the Ilana or Chi and I think Poramate have put this tactile touch sensors in their robots, but I think they implicitly thought of these principles in their design of the robots, right? So I just want to ask everyone, who work on touch sensors, whether saccade-like principle you can observe in your experiments. I don't know who want to start. Poramate, maybe you can just start.
Yeah, I think this is a really good point, Fumi. So because what we see in robotics now, we differentiate two things, like like the touch or tactile sensors that come like on the contact point interactions, and the thoughts interactions. And the other part is about the long distance perceptions, like visual information, stuff like that. And one thing we are looking into this is that first, how can we focus or filter information, like Tris mentioned, like, like using some attentions to focus the important area of feedback that we can, filter information. That's one thing. The second thing we are looking at the moment is that how we can correlate multimodal informations from for example, different time aspects. Information come at the first, second, and third, and so on. How we can correlate this information that could make like more proactive way for robotics also to behave. Yeah, I think that's something we are. Yes.
Yeah, in terms of the rehabilitation, so when I go to like hospital and observe those like patients, especially like for the children, I think like they kind of like forget their like limb. So they do not really recognize their food. So they have like very low sensitivity from their like food. But after the physical therapist at their like stimulation, they kind of like suddenly recognize, oh, I have like food. I'm standing like this. And so that is actually very important. However, like the patient still could not really fully stabilize their postures. But then I think their like body shape is very important for the like robust, like to the like external change. So as I mentioned, like they have like arch to kind of absorb the shock and stabilize the posture. So due to those like noise or like weak sensors, but still they could use their body structure to somehow like interact with the environment. And I think that is a very important point and interesting point to discuss.
Maybe another thought, if we're talking about saccades in the visual systems, for the tactile system and the haptic system, it's even a richer form of active sensing, right? There are the exploratory procedures. So depending on what we're trying to infer, we will employ different exploration strategies, and we maybe press on the object or slide my hand along the object, or grasp it or shake it, or get some kind of rich aspects of this physical interaction with the object. And I mean, this is definitely something that worth to explore robots to be doing. And the other thought is the fact that the skin as a sensor on the biological system, right? It's not limited to different regions in the body. So if I'm touching an object with my fingers, vibration waves sort of propagate through the entire skin to different other parts of the body, making actually touch sensation so difficult to isolate, right? If I want to eliminate my touch sensation at the fingers, and I will even anesthetize my fingers, I would still get some haptic information from this interaction. So this is another thing. So kind of in favor of, in thinking about the body of the robot, the sensors should somehow be physically coupled across its entire body, and then the processing will be, of course, much more complicated, but then it will be a benefit to the sensory capability.
Yeah, fully
Yeah,
agree.
exactly.
Touch is very, attention in touch is very complicated. What we see in our experiments is it is fingers, at least in object recognition, palpation, fingers don't not only move around and control their force as like our saccading eyes. They also control posture, stiffness of fingers, and so many internal things, right? So there are actually two processes going on: internal tuning of kinematics, and then external dynamic interaction control. So it is a rich form of saccading in a way, like, because eyes can only just orient, but fingers can do multiple things. Like, I think is a very rich form of paying attention to object mechanical features, texture features, and multiple features. Yeah.
Yeah, I agree with you. So, 25 years ago, I was on my topics was on sensor fusion with ears and then eyes using a humanoid head. And we get an result about if we got an image, and we can get an height and with something like that. But in our auditory system, we can get not only ears, but a head type vibration transmission. So it is very easy to understand what is going on, and vibration is the same to the sound, right? So I understand Irania. So that is very difficult to understand what is going on and vibration and the auditory system and touching everything. Yeah. But now we can get fundamental models, and we use an IMU and the auditory system, everything, and then getting the data and understand and learning system is getting what is going on inside of the robot and then what is going on the outside. So it is very interesting to make robots.
Well, and also again, I think what is important to highlight is that also the physical structure of the different sensors is really impacting a lot of the exploratory procedures and the processing, right? Because I mean, first that example of the full skin, also the fact that we have the fingernails, right? That artificial sensor that I'm blanking on the name, but the finger that had this artificial fingernail that helped the propagation of the waves in the sensing and increase the signal essentially.
There is another questions from the audience. I think I could read this for you. To what extent should robot be decided to replicate or surpass human capabilities? This is going to be interesting. And if we do so, can we, will that increase our understanding of intelligence and the role of human in the future, in future society? So basically, so I think that I just try to summarize the question. So should we just try to build a robot that having behavior or performance equal or surpass human capability? If we do so, will be able to understand intelligence in the general aspects, or how will that reflect to our future societies?
So already JCB robots can do a lot of things human cannot do. They can work in teams and they can lift the heavier objects. I think this whole thing about human-centric thinking is not the way to understand intelligence. So, I mean, as a species, we have been tool makers from Neanderthal times, right? So anything is an extension of our intelligence, and then it is just adding on top of our intelligence. It is not replacing or anything.
Actually, I'm thinking opposite to Thrish's position, because I think there's so much that we don't know how to replicate in terms of what human can do but robot cannot do. And looking at what the Ilana is talking about, how human does the planning before grasping things, and I think that is leading to how to generate the intention of doing something, or how we can do prediction, how we can do preparation, how we can do a lot of sequential things, more dexterous way. And looking at the first plenary talk of this conference in Nikki Clayton talking about how human or animals can break the magic, right? How they can discover what's the intention of your magicians and so on and so forth, right? And this is a very interesting interaction in much, much higher level than what our today's robot can do, right? So the robot can predict the prediction of your opponent, and then you start cheating against each other. And that is the kind of reading between line, leading the intention of your partners, your others, and fighting against each other, but also cooperating against each other. I think that this is the kind of direction that we still don't know how to do in our robotic systems. And that is actually the question I wanted to ask, especially Ilana, like how you think about it, because you certainly trying to go beyond just, rather basic reaction to sensory stimuli, but integrating, prediction, understanding, and hopefully generating some intentions and so on, right? So I don't know what you think, Ilana.
Yeah, thanks. It's a tough question because, well, so first of all, there's this, I think there is a clear distinction between trying to understand what humans do, or animals for that matter, and trying to come up with a model that would at least be compatible with the outcomes of our actions, and not necessarily replicating what we do, but kind of at least creating compatible responses. And then there is the question of, building a robot that will employ the same processes, and maybe it will be better than a human and maybe not. But then once you've came up with enough like details in that functionality, how do you even benchmark that, right? Because if I'm thinking about a cognitive decision task of playing a game of chess or any other game that has rules, that's one thing, and the reasoning there is very clear. But then when you have these arbitrary scenarios of decision making, in surgery, you decide, you interact with the surgical site, you perceive the sensor information, you add this medical decision, you gamble a little bit because there's a lot of uncertainty about what actually happens with the patient. And then you put that into action, and then some process happens together with the healing of the patient, and you can judge the outcome. But then how do you benchmark that with a similar interaction of the robot with, you can't even compare this interaction on the same patient, right? So it's tricky to think how to come up with this benchmark, this Turing competition for these abilities for the robots.
I thought it was really interesting. Oh, hey everyone, I'm Nana. I thought it was really interesting, what Fumiya mentioned with future consequences of the first day of Nikki, and then also what she mentioned of people being able to perceive reachable distances after they've been impaired as well. I also find the part where what Kento introduced, Kento Harazuka, with all of the robotic systems combined, them being able to enhance and augment their capabilities beyond what is normally possible for a human or any just one robotic system.
I think
Actually, for the rehabilitation, actually now I just mimic the physical therapist intervention for the robot. But my goal, dream, is to how to say, to go over beyond the human physical therapist. For example, the human can only manipulate with these 10 fingers, but we can develop the robot with a lot of stimulation point. Maybe that enhance much more improvement in the body functions. But if we can do that, maybe humans can, maybe it's not easy to change their body structures, but the human can learn their skill of the robot, not from the robot learn human behavior. Human and robot can co-evolve, they go kind of compete each other and to get higher stage. That is my thought.
Maybe another thought, and not necessarily related to how robots can outperform the humans, but in our design thinking, right? When we're designing robots, we're kind of trying to think about a particular phenomena or particular function and how to best address this function with the body of the robot and also with the control algorithm and everything. And then for the biological systems, often many things happen without any understandable reason, right? Why do we have the tickling mechanism? Why do we have all sort of phantom sensations? Why do we have even the illusions, like the sensory illusions? I'm not sure we can understand like the practical purpose of these concepts. And then maybe one way to build these super robots or to build this kind of embodied intelligent robots would be of trying to implement many aspects of the biological function that are not very easy to understand why they're there, but just try to put them into the system, including the not very perfect sensors, including the many sensors, the redundancies, everything, and then see what happens.
I like this point of Irena, like because when we start to implement some function into robots, one thing we also have to consider, but I think if we can ignore that, focus mainly on biological system, that would be really cool. Because most of the time we have to look at what is the applications of this, but then we cannot answer that, okay, phantom effect, what is the application of that? But I think on the other hand, if we look into these directions more, like, ignore about application wise, but try to understand what the virtual system, demonstrate or exist in that, then might be interesting to tackle these questions. And another thing I'm just wonder, like, say, if we have embodiment system that can replicate those functions, the next thing I'm not sure how to do that is how we can understand the mechanism inside. Let's say we can have, like big network, whatever, that can do multi-sensor modality transformations and then execute certain complex behaviors. But then if we want to look inside that complicated networks to really understand what does it do, I think that could be something that is another challenge, that we need to break down this complicated network into probably subcomponents into modular approach or something.
Mm-hmm. I think we have to also pay attention to the let's say market forces also, right? So like why we will have some kind of a settlement between robots and humans that settles with the best commercial viability and value addition, right? So like robots, is there a reason why robots should replace humans? There's no way, right? So there's no reason, commercial reason for that. So whatever, I mean, we can make robots to understand human embodied intelligence. That's a theoretical understanding, and then that will have some extensions. But like, what will practically happen is we will settle down with the optimum mix with best scalability and commercial viability.
Poramate, I think there are a couple of questions from the audience.
Yes, so
Yeah, so
I'm trying to pick some now. The next one probably coming back to the humanoid, both from the perspective of Robert this morning and Nikki on Monday. Is this the right platform to be explore intelligence on? Like, should we use humanoid robot now as the like standard platform to explore multi-sensor modality and complex behaviors? What do you think about this?
I think this is depending on the situation. It is good for the humanoids, and the other is a robot arm, other is just a machine or a sensing system like that. So it is not only for the humanoid, I think.
Mm-hmm. I think humanoids are a great platform to understand who we are, because that allows us to have a comparable morphology. And then, but the problem is like outer appearance of a human is not everything, right? So
yeah,
It is like it's very in details, like how the fingernails, for example, we are studying the shape of these fingernails. What do they do as haptic lenses? And then the shape of bones that are not seen from outside, right? So the scan profiles of the knee joint. These are the real computers, right? So that take forces and map them into intelligent information, for example. Lots of things are happening inside the body that cannot be seen from outside. Intelligence, and even the microbiome we have in our guts that is intelligent on its own, and like we are, I think, more than 90% of microbiome. So there are so many things that are, we cannot really reduce this to the shape of a human. So it is my feeling is the shape of the human is about 5% of the story. The bigger picture is inside, but it's a good platform to understand.
Yeah. What do you think of the size of the humanoids? So, for example, almost 25 years ago, and I had an operator of the humanoid Ashimo, and what is an 130 centimeters height. And also, right now we have many types of the humanoid, 150, 70, or something like that. And what is a good size for the humanoids?
It is not just the size; it is the weight too. Like, so if we can make a robot that is of roughly like 6 foot, let's say maximum, and then like 100 kilograms maximum. Because the kinematics and dynamics both do matter, right? So like all the model-based controllers, our sensory systems, everything is dynamically coupled with other systems. So if we make a very heavy robot and dynamically not at all similar to humans, we don't understand how we couple with the rest of the world.
Yeah, so heavy robot is very scared.
Yeah, exactly.
Yeah.
I have one question, maybe for Trish, maybe you also for others as well. Like, what do you think about the emotional aspects of, like, for example, embodied emotion? Because the question is like whether we can kind of use humanoid as like a platform to kind of understand human emotion. What do you think about that?
I mean, emotions, like there are, I think this is where we are getting tricky, right? So there are quantifiable, measurable things and non-quantifiable, non-measurable things. Like there are, emotions. For example, like how do you sense love, right? How do you measure sadness? And these are partly chemical, partly electrical, right? So it is in the microbiome. Sometimes it is a secretion of hormones and things like that. It's far too complex to be captured using chemicals and electrical circuits we know today. So we are way behind understanding that side of the story. Yeah.
But Tilina and Trish, you both work a lot on phantom faces or phantom humans for surgery, and you also produce faces as well. What is the most important feature of the face to convey these kinds of emotions usually?
Like there are primitives. I think probably Trish can support me as well. So action units. These are like the primitives of the facial expression. So as Trish said, like there are a lot of other things we need to consider because these are the appearances. Like the outer appearance is like based on the action units or these primitive motion primitives. But I think if you go deep, I think it's all about even the neuroscience or the cognition, all these things, because it's quite difficult for us to quantify the emotion, as Trish said. I think we are very, we are not actually there to kind of, quantify emotions, in my opinion. Maybe, I don't know, maybe Trish might have a different idea.
Yeah, I think I mean this is where we will settle down with the resolution between humans and robots.
Yeah.
Humans are way too complex when it comes to emotions, and even if we have a robot that can do that, it will be extremely expensive. I think commercial settlement is also important, right?
Yeah.
So it's all driven by market forces. Like I mean, take for example Amazon robots. So Amazon didn't fully automate their warehouses, right? So they just said we will reduce human walking to by 80%. So then they kept a 20% mobility for humans. Like so, it is good for their health and their sense of belongingness, engagement in the workplace. They didn't freeze human motion to zero. So 80% capture by the robots in this massive warehouse was good enough settlement. So that is why I think it's really important for the robotics community to think about the market forces too.
I think that could be the reason why maybe almost all the human robots nowadays, like they don't have face. I mean, they literally have like maybe
Is there a need? Is there a commercial
like
need?
couple of exactly.
So maybe one thought about this whether it has to be a humanoid, and especially of the size of the actual human, and maybe kind of linking into the emotions or building a picture of the world. This topic has been discussed a little bit in when thinking about the inclusiveness in design, right? Because your perspective varies a lot by your physical height or whether you're sitting down or standing up. So I remember very strongly my experience at the conference back in Edinburgh when I was pregnant, and I needed to sit a lot, and a lot of my conversations were while sitting down. And my experience, and even thinking about the cognitive processing of the content of the conversation, even not haptic exploration or anything, was altered by this experience that is related just to the height of my sensory unit. And in this sense, maybe I don't know if it's been explored, but if we think about whether a human body is needed for studying intelligence, I think this is something that needs to be considered. Also with the practical implications that are related, again, circling back to the inclusion aspect.
Mm-hmm.
Yeah, really important point. Yeah. I think Robert mentioned height is one thing, reachability, slenderness for narrow spaces, and then we need legs because we need to walk on rough terrains, and then also we need power because we need to do a lot of energy demanding things. Yeah.
It is really important. I remember before my daughter was born, the hospital advised us to crawl like a baby in the house and then see how your house looks like from your upcoming baby. And we saw a different house, like all the dangerous things, like power sockets and all everything you don't see from your height, right? And then we could take action like that. It's super. It's very eye-opening, the kinematics, and then the world we perceive.
Yeah. I think there's another. Oh yeah. Okay. Go ahead.
So this comes down to this question about, Thresher coined term about the ghost circuits, right?
Yeah.
There are lots of ghost circuits implemented in our body, and we don't see them until we encounter the situation, or we encounter the situation. And it's easy to say that their ghost circuit exists. But the question is, how are we going to understand it? How are we going to design this, right? And if you look at the human body, we have 5 fingers, right? And these 5 fingers, is there any reason behind it? Of course, in some cases, yes, and other cases, no, right? And then so if you have to design those circuits, it is just a matter of memory that you experience this, but that's why we keep this function in our body. Or is there something designed for emergence? Like we didn't experience. We didn't plan to have this situation, but somehow it's there, right? So that's the kind of two cases where understanding a ghost circuit. But if this is just an experience-based memory in the design, then we just need to put more and more and more mechanism in the given, the volume, surface, and the structure. So I think that is the kind of one step beyond, just saying ghost circuits exist. And I think that's a really deeper question about how we should think about the embodied intelligence in the future.
Exactly. So the current method we are proposing is a thing called a situated heuristics based design approach, which is like you cannot see a ghost circuit unless you encounter the contact, right? So the contact establishes the ghost circuit, and then the dynamics emerge. For example, the mountain goat hoof design, you can start with a simple hypothesis and then test it in a real environment. Then you see the limitations of your design in coming closer to the mountain goat, and then you keep adding features till it converges to some kind of a reasonable behavior. And then what happened in our case was like all our initial hypotheses were wrong. They could not come even close to mountain goats. And then once we exhausted all our very egocentric assumptions, then we were humbled by very simple features that could really do the magic, right? So what practically happens is, again, coming back to the shape of the human thing, we think what is really important is the shape of the human, the humanoid, or the height or the weight. Actually, when you really then build a robot that looks like a human, it cannot walk 2 meters without falling, and then you realize, hey, there's something missing, right? So here we so then you really get humbled by these experiments, and then you fall back to the basics, and you discover the basics of these ghost circuits. And then one day we will realize that the secrets of all those ghost circuits were within the body, not outside the body. And then, details of cam shapes and bones, and why the distal phalange had that shape, proximal phalanges that had shape, metacarpal joint has, trapezium joint has that shape, ankle joints have all those ball bearings, like all that. Like though, I think the secrets are in those details, and then we have to do very basic experiments to understand ghost circuits rather than testing things in a very integrated, complex system. I take that like like how Newton did the experiments, like to understand the third law, he had just a pulley, a mass, and a stopwatch. So I think that kind of experiments will help us more.
Right. I think it comes to closer to the end, and I just want to ask Yuki the final question that we came across this topic of humanoids in the last 2.5 days, and lots of people interested in humanoids or curious about humanoids, or maybe don't like humanoids. I think the humanoid are really interesting platform for discussion and arguments, and you're the only business person in this conference in the last 2.5 days, and I want to hear your opinions how this is going to go, and what's your expectation, or you like humanoids, you don't like humanoids. What do you think about the future of humanoids in the next 5 year, 10 year, or maybe in 100 years?
Yeah, that's a good question. I love humanoid robots because my relationship with the humanoid robot is from almost 30 years ago. Yeah, at that time, the humanoid only radio control car motors used for the humanoid robot. These days, all over the world, researchers wanted to develop the humanoid robots using the AI, and especially generative AI or fundamental model or something like that. So that was very interesting. But I think that it's in a very early stage for the humanoid robots. So humanoid robot is originally artificial intelligence researchers in the 1950s. They think about artificial intelligence based on the embodied AI. So they think about AI is realized by the robots. So that is the humanoid is focused on other research topics. So humanoids, robots, thinking about what is a human and what is an intelligence and what is an functionalities, many things inside of the humanoid robots. Researchers want to make clear. So I think that right now, humanoid robot research is on a very early stage of the humanoid robot development. So I think that it is good in next decade or 20 years ago, and it's a very exciting age for that humanoid robots, around 2040, 2050, something like that. So I'm very excited that how we can develop the humanoid robot. And right now, we aim to use a humanoid robot to the factories. So that is on a very early stage, but 5 years later, next decade, and we think we work with robots. And after that, and we will live with humanoids in the form, maybe.
Yeah, well, thank you.
Yeah, as
Thank
is
you.
the
Thank you for,
television is a thing.
yeah.
Yeah.
Yeah, thank you. Thank you for the comments. I think humanoid robot has a kind of ultimate question for the embodied intelligence researcher, partly because we are human, we're all humans, and we are curious about our own embodiment. But on the other hand, it's not just a matter of shape, it's not a matter of size, matter of weight. I think there are lots of things behind the embodiment of our body, including the notions of gold circuits and so on. Why do we have 5 fingers? Is there any reasons, or maybe there's no reason, but there's some hidden mysteries behind it? And these are all questions that we need to discover in the coming years and decades, I think. All right, I think it comes to the end of the session. So thank you very much, everyone, for very stimulating discussions, and hopefully everyone enjoy as much as I did. And the Poramate, thank you for chairing the session. And the Tilina, thank you for chairing the whole morning session today.